All right, guys, so this is going to be 11.5/6 area ratios and volume ratios. And these are going to be for similar figures. So you can see all these little pairs of figures, geometric figures, they're all similar figures. So let's start off with the first investigation. This is going to be related to the ratio of their perimeters, okay? So it says draw a triangle and label the sides with any measures, and then you're going to calculate perimeter. Then you're going to multiply each dimension by a scale factor. So you get to pick that scale factor. So let's start off with a small triangle. Let's say this is 3, this is 4, and this is 6. Okay, so this perimeter is going to be 13. Now it says multiply each dimension by a scale factor and draw an enlarged one. So we're going to keep it simple and we're just going to double. So this will be 6, this will be 8, and this will be 12. So now let's add this up, and it says find the perimeter of this one. So 6 plus 8 is 14, and 14 plus 12 is 26. Okay, so it says what's the ratio of the side lengths of the two triangles? Okay, so I'm going to highlight just these two sides, 3 and 6, and then 4 and 8, and then 6 and 12. So when we look at that ratio, 3 to 6 is that first ratio. Then we also have 4 to 8, and we also have 6 to 12. All of those sides reduce from 1 to 2. So the ratio of the sides is 1 to 2. Okay, so the side ratio is 1 to 2. What's the ratio of the perimeters? So let's take a look at the perimeters. So the perimeter ratio is 13 to 26, which, what does that reduce to? 1 to 2. So what do we know about the side ratio and the perimeter ratio? They are the same. Okay, so these are always going to be the same. So the side ratio and the perimeter ratio is always the same. So if the sides go from 2 to 3, well, the perimeter is also going to go from 2 to 3. Okay, so let's check it out one more time. It says find the exact circumference of these two circles in terms of pi. So circumference is the same thing as perimeter. Okay, so the circumference of this one is pi times diameter. Okay, diameter of this little guy is 4. So the circumference is 4 pi. The circumference of this bigger circle is 10 pi. Okay, so now let's write the ratio of the two circumferences. It's 4 pi to 10 pi. Now remember, you can write these as fractions as well. 4 pi to 10 pi. So you'll notice that if we reduce this, we can cancel out the pi's, and the 4 and the 10 can also get reduced to what? 2 to 5. So the ratio of the circumferences, which is kind of like the perimeter ratio, is 2 to 5. Now it says, look at the radii and write the circumference of that. So the radii are 2 and 5. What do you know? It's the exact same thing again. Okay, so these are the same. Again, the circumference ratio was 2 to 5, and then the radius ratio. So radius ratio is also 2 to 5. So they're the same. So here's a conjecture that you need to always remember. If the corresponding side lengths of two similar polygons or the radii of two circles compare to the ratio of A to B, Well, then the perimeters are going to compare in the ratio of the same thing, A to B. Okay, so fill that out in that blank. All right, so that was easy. Let's go to something a little bit more challenging. Okay, it says draw a rectangle and label the sides with any measures. And then we're going to calculate the area this time. So we're not doing the perimeter. So let's start off by drawing a small rectangle. Okay, and let's pick easy numbers. Let's say this side is 2, and let's say this side is 4. Now it says multiply each dimension by a scale factor and draw the enlarged similar rectangle. Calculate its area. Okay, so let's do, oops, I forgot to do the area over here. So let's do the area. Area over here is 8 units squared. Okay, so I'm going to not use the same scale factor that I used last time. I'm going to use a scale factor of 3. Okay, so our scale factor is going to get 3 times bigger. So let's say that's 6 and that's 12. So what's the area of this going to be? So all of these got 3 times bigger. So the side ratio is 1 to 3 because all of them got 2 times bigger. Remember, this was 2 to 6 and then 4 to 12. So the area is 6 times 12. What is 6 times 12? 72 units squared. So what's the ratio of the side lengths? It says large to small. We're going to just keep it going left to right. So I'm going to cross that out. So it's going from 2 to 6 and 4 to 12, which we just reduced over here. And we said when we reduce those, it's 1 to 3. So that's the side ratio. What's the ratio of the areas? So now let's do the area ratio. So area ratio is 8 to 72. 8 to 72. Do you think that reduces 1 to 3? No, 8 goes into 72 9 times. So this actually reduces 1 to 9. So it's not the same as that. Okay, they're different. So this is a different scenario other than like the perimeters. So what do you notice? Well, the 1 stayed the same, but the 3 changed. The 3 now changed to a 9. Think about this right here. This is in units squared. This is in units squared. Remember, this is just regular units right here. So like when I say units, like this could be 2 inches, 4 inches, 6 inches, 12 inches. That means this would be 8 inches squared. 72 inches squared. What do you know about the 3 to the 9? Well, if you square the 3, doesn't that give you 9? Okay, so that's something to think about it. Let's look at it one more time over here in this next example. It says find the exact area of these 2 triangles and then write the ratio of the areas and then reduce, and then it says do the same with the side lengths. So let's check out the side lengths. So the side lengths are 2 to 8 and 3 to 12. So 3 to 12, 2. So let's actually write that down over here, the side ratio, because it says we have to do that right here with the side length. So the side ratio is 2 to 8 and 3 to 12, which what do those 2 reduce to? 1 to 4. So the side ratio is 1 to 4. So all of these sides got 4 times bigger. So now let's focus on the area. So the area equals base times height divided by 2. The area of this guy equals base times height divided by 2. So this reduces, so the area of this first one is 3 square units. And the area of this guy is 48 square units. 3 and 48. So now let's write that down. Let me pick a different color. So the area ratio is 3 to 48. Does that reduce? Let's check to see what that reduces to. How many times does 3 go into 48? And that goes into it 16 times. So this actually reduces 1 to 16. So the area ratio is 1 to 16. So how do those two compare? Okay. Again, we had talked about on this last slide right here, let me get my highlighter, how this 3 changes to a 9, and it's simply 3 squared. So it is related to the 3 if we just square it. Now let's look at this one over here. This 4 goes to 16. And so that's kind of the same situation there. If we take 4 and we square it, that becomes a 16. Okay. Now I know you can't really tell in the ones, but what happens when you square the 1? What's 1 squared? 1. So if the corresponding side lengths of two similar polygons have a ratio of A to B, okay, so the side ratio is 1 to 4, A to B, then the area ratio, so when you square the 1, it gets to be just 1. And so really you're squaring both of them. So the way you want to write out this last conjecture is if the side ratio is A to B, then the area ratio is going to be A squared to B squared. Okay, and I'll show you how we're going to use those here in a minute. So let's look at these examples. Okay, so here we have these two similar polygons, and I know it doesn't say they're similar, but they are. So these two are similar. You have this side length is 5 and this is 7. So the first thing you should write down is the side ratio is 5 to 7. Okay, and I know it's not a pretty ratio, but that is what it is. Then it says, I know the area is 40 inches squared. What is the area of the bigger one? So here I want to show you what probably a lot of y'all are thinking right now. You're probably thinking that you want to write out a ratio 5 is to 7 as 40 is to x, because we're finding the area of the large pentagon. The only thing is we cannot use the side ratio to solve for an area, because you have to remember that this is inches squared. This is going to be inches squared, but the 5 is really just inches. And so when you're in different units, you cannot do that. So how do you make the adjustment? Well, remember, we had talked about what the area ratio would be on the last conjecture. So the area ratio is whatever the side ratio is squared. Remember, A, if this is A and this is B, well, then this is going to be A squared to B squared. So 5 squared, I don't know why I put plus. 5, A squared to B squared, 5 squared to 7 squared. So what you really needed to do is square the 5 and the 7. And now you can cross multiply to solve for the area. So you don't need to know the dimensions. And I know you probably want to go through and draw an opossum and then use a right triangle. You don't need to do all of that. All you need to do is this proportion right here. So now let me use the calculator to figure this out. We have to do 7 squared times 40. That's 1,960 equals 25x. I'm making it 25 because I know 5 squared is that. So now I just need to divide by 25, and that's 78.4. So the area of the big pentagon is 78.4 square inches. And that's our answer right there. All right, let's try another ratio proportion problem with area. So it says if you need to cover a medium 12-inch diameter pizza, How much shredded cheese would you need to cover a 16-inch diameter pizza? So cover is, and this is where some students kind of don't really understand this problem. When you think cover, you're covering the whole pizza, which, what is that? That's area, okay? So the side ratio or the radius ratio is 12 to 16, which that reduces 6 to 8. Okay, that's the radius. Okay, so then we can reduce it more. That reduces 3 to 4. Okay, so that's the side ratio. So here's what a lot of y'all are going to do. You're going to take 3:4 as 3 ounces is to X ounces. But you have to remember that we cannot do 3 to 4 because that's only associated to the side length. We have to think of area because we're covering the whole pizza. So we have to do 3 squared is to 4 squared as 3 ounces is to X ounces. Okay, so I'm going to highlight those. And so you have to make sure that you put that squared whenever you're dealing with area. Okay, because you're in a different units, okay? So where's my pen? There we go. So now let's cross multiply. So 3 times 4 squared is 48 equals 9x. I wrote 9 because 3 squared is 9. I'm going to divide by 9, divide by 9. So x equals, what's 48 divided by 9? 5 1/3, 5.33 repeating. So you need 5 1/3 ounces to cover that bigger pizza. Okay, let's go to the last one. It says the ratio of the areas of two similar trapezoids is 1 to 9. So you have a small trapezoid and you have a big trapezoid. Okay, and the area of this small one is some small number, and the area of this large one is a larger number, okay? But we're going to say that it's 1 to 9, okay? That's because that's what it reduces to. Okay, so the area of the small one is like 1, and the area of the large one is like 9. So it's asking what would the ratio of their altitudes be? So let me draw in the altitude. Here's an altitude. And there's an altitude, meaning the height of the trapezoid. So a lot of y'all might think that, oh, well, if the areas go 1 to 9, then the altitudes are going to go 1 to 9. But no, because you have to remember the side ratio is A to B, and the area ratio is A squared to B squared. Well, remember, this is like 1 to 9 over here because they gave us the area ratio. So how do we go backwards? What do you think you do to get rid of the squared? You square root. You have to square root both of them. So your final answer for the side ratio would be, what's the square root of 1? 1. What's the square root of 9? 3. So the side ratio would be 1 to 3. All right, so you have to just make sure you're using the area ratio whenever you're solving for areas. All right, let's go even a little bit more challenging. Let's look at the volume ratios. So it says draw a rectangular prism, label the sides with any measure, calculate its volume. Okay, so let's keep it simple. Here's how you draw a rectangular prism, guys. You start off with drawing a rectangle, and then I draw 3 somewhat congruent segments going off and to the right, and then I just connect those. And there you go, you have a rectangular prism. So let's put some easy dimensions on here. Let's say this is 2, let's say that's 4, and let's say the height is 3. Okay, so now it says calculate its volume. Okay, so we just finished doing volume. Volume is base times the height. So the area of, oops, I wrote that wrong. Now that I just see how I labeled it. Let's put the 3 right there. So the volume area of the base is 4 times 3, which that's the area of the base, times the height, 2 is 24. 12 times 2 is 24. So 24 units cubed. Okay, take a mental note of that. We're now in cubic units. So that's different from square units and regular units. Now it says multiply each dimension by a scale factor and draw an enlarged rectangular prism. So let's pick an easy one. We'll go back to just scale factor of 2. So we're making it larger. So that means this is going to be 4, this bottom side is going to be 8, and this one's going to be 6. Now, since all the sides got twice as big, so that means our side ratio is what? 1 to 2, because all the sides got 2 times bigger. It went from 2 to 4, 4 to 8, and 3 to 6. So all of those reduced to 1 to 2. So the question is what's the volume of the big one? Is it going to get twice as big also? Let's figure that out. Area of the base is 8 times 6, which is 48, times the height, which is 4. So 192 cubic units. So the volume ratio now is 24 to 192. Well, that's probably definitely got to reduce. How many times does 24 go into 192? 8 times. So this reduces to 1 to 8. So the question is, how does that relate to that? Well, you might say, oh, 2 goes into 8 4 times, but 1 does not go into 1 8 times. So think about what happened when we did the area. Remember, we squared it. What do you think you do to the 2 to get the 8? You cube it. What is 1 cubed? 1. So 2 cubed is 2 times 2 times 2, which is 8. Okay, which makes sense to cube it because we're now in cubic units when these values all right here were just regular units. Okay, so the volume ratio got bigger by cubing the side ratio. Okay, let's try it one more time. So we have these 2 similar cones and it says find the exact volume of each cone. So if you don't remember the volume formula for a cone, it's 1/3 capital B times H. And then capital B is pi r squared because the base of this is a circle. So the small one is going to be 1/3 pi 2 squared times the height. Okay, so now I'm going to simplify this. This is 1/3 times 4 times 6 times pi, which 4 times 6 is 24, and what's 1/3 of 24? 8. 3 goes into that 8 times. So the volume of the small cone is 8 pi, and this is cubic feet. That's what the little tick mark means. It's cubic feet. So now let's do the volume of the large cone. 1/3 pi 8 squared times the height. Okay, so these are numbers. I get my calculator. 64 times 24 is a big number. 1/3 times 1,536 pi. And then 1/3 of 1,536, I'm going to divide by 3, is 512 pi. So that's the volume of the big cone, and this is cubic feet. Oops, I wrote that wrong earlier. Sorry, guys. Let me go back in. You probably caught it before I did. Good job. This is cubic feet. Okay. because we're now in cubic units because that's volume. So let me go backtrack and do the side ratio. What is the side ratio? Let's write it over here. The side ratio is 6 to 24 or 2 to 8, which what do both of those reduce to? 1 to 4. So that's the side ratio. What is the volume ratio? Okay, the volume ratio is The volume ratio is 8 pi to 512 pi. Well, guess what? The pi's cancel, and I definitely believe that 512 is divisible by 8. 8 goes into 512 64 times. So the volume ratio reduces 1 to 64. So what does that look like? Well, 1 cubed is 1. What is 4 cubed? I bet you anything it is 64. 4 times 4 is 16 times 4 is 64, and that's right. So that takes you to this conjecture. If the side lengths of the radii of the 3D figure, meaning the radii or the heights or any part of a 3D figure, then of the two semi-solids is A to B, then the volume ratio is going to be A cubed to B cubed. Okay. All right, so you got to know the difference. Okay, so just because the side lengths get bigger by 3 times doesn't mean the areas or the volumes do. So let's kind of put it all together here. Okay, so we have these two similar prisms. And it says the surface area of the large prism is 300, and then they gave us the volume of the smaller prism here in blue and here in red. And then it says the area of the base of the small prism is 9, and the area of the base of the large prism is 25. So I want to highlight this right here. This is something to take note of. This ratio right here, which can be written as a fraction or as a this way right here using the colon. That means the same thing, okay? Which ratio is this that they gave us right here? What ratio is that? 9 to 25. Well, look at this right here. It's the area ratio. So if the area ratio is 9 to 25, what is the side ratio going to be? What do we do to that? Well, we kind of talked about it earlier. When you go backwards, all you have to do is square root those values, which that reduces 3 to 5. So the side ratio is 3 to 5. So when they ask right here, what is H to capital H, that is 3 to 5 because we want to square root the area ratio. Okay, so that's 3 to 5. That is the side ratio. So if you want to write side ratio right here, you can. So what would the ratio of the volumes be? Well, think about it. If you have the side ratio, all you have to do is cube the side ratio, and that's the ratio of the volume. So I actually don't mind if you leave it like that, 3 cubed to 5 cubed. If you want to, you can multiply it out. 3 cubed is 27, and 5 cubed is 125. So either one of those is fine. And so now it's saying, what is the surface area of the small prism? Okay, well, you have to use this piece of information over here, the other surface area, which is right here. Okay, so they gave us the surface area of the large one, then we can write a proportion to solve for that. Now, the only thing is you better make sure you use the correct ratio. If we're finding area, you want to use the area ratio. So that's 9 is to 25 as, which one did they give us? The large one. So X is to 300. So now let's cross multiply. 300 times 9 is 2700. and that's 25x. So I'm going to divide by 25. And how many times does 25 go into 2,700? 108 times. So this is 108 centimeters squared. Okay, one more. Color do I not use? Let's use orange. So volume. I have to use the correct volume ratio. So I'm going to use 27 is to 125 as, because I know the volume of one of them up here, and that's the smaller prism. So I'm going to put 324 on top with the smaller number and x on the bottom. So let's cross multiply. 125 times 324, which is 40,500 equals 27x. Divide by 27. And we get 1,500. And this is centimeters cubed. And that is it.